A cubic function has the form fx equals ax cubed plus bx squared plus cx plus d, where a, b, c and d are real numbers and a is not equal to 0. The graph of a cubic function can take several different forms depending on the exact nature of the function. So first, let's take a look at a few forms of cubic graphs. If we take a look at these sketch graphs, the cubic graphs take this form when a is positive. When the coefficient of x cube is positive, the graph would start from the top right and goes to the bottom left. You could say that when x goes to infinity, y goes to infinity, and when x goes to minus infinity, y goes to minus infinity. These are few forms of cubic graphs when a is negative. So when the coefficient of x cube is negative, the graph would start from the top left and end at the bottom right. If we were to make it clear, you could say that when x goes to minus infinity, y goes to infinity, and when x goes to infinity, y goes to minus infinity. You can easily sketch the graphs of a cubic function by finding the roots of the function. For example, y equals x minus 1 times x plus 2 times x plus 3. When y equals 0, x equals 1, x equals minus 2, or x equals minus 3. So, the curve crosses the x-axis at x equals 1, x equals minus 2 and x equals minus 3. When x equals 0, y equals minus 6 and the curve crosses the y-axis at minus 6. So before sketching our graph, let's find the coefficient of x cube. So here, expanding the first two brackets gives us y equals x squared plus x minus 2 times x plus 3 and the coefficient of x cube is 1. So the curve has a positive x cube coefficient and your graph would look like this. Y equals x plus 1 times 1 minus x times x plus 3. When y equals 0, x equals minus 1, x equals 1 or x equals minus 3, and when x equals 0, y equals 1 times 3 equals 3. So, the graph crosses the x-axis at the coordinates minus 1, 0, 1, 0 and minus 3, 0, and the y-axis at the coordinates 0, 3. So, y equals x plus 1 times 1 minus x times x plus 3. Expanding the first two brackets gives us y equals minus x squared plus 1 times x plus 3. The coefficient of x to the power 3 is minus 1 and hence the curve has a negative x cube coefficient. So, the graph would look like this. Y equals x plus 1 squared times x minus 1. When x equals 0, y equals 1 squared times minus 1 equals minus 1, and when y equals 0, x equals minus 1 or x equals 1. Here, the coefficient of x cube is 1 and hence the graph would take this shape. Here, x equals minus 1 is a double repeated root. Y equals x minus 2 to the power 3. When x equals 0, y equals minus 2 to the power 3 equals minus 8, and when y equals 0, x equals 2. So, x equals 2 and the curve crosses the x-axis at 2, 0 only. Here, the coefficient of x cube is positive and hence the graph would take this shape. So, if you take a look here, you can see x equals 2 is a triple repeated root. Y equals x to the power 3 plus 5x squared plus 4x. First factorize this equation before drawing the graph. So, take x outside as x is a common factor. Then, it's y equals x times x squared plus 5x plus 4. Now factorize x squared plus 5x plus 4. So, it's y equals x times x plus 1 times x plus 4. Now, when x equals 0, y equals 0, and when y equals 0, x equals 0, x equals minus 1 or x equals minus 4. The coefficient of x to the power 3 is positive, so the graph would take this shape. Y equals x to the power 3 minus x squared. Factorize, so it's y equals x squared times x minus 1. When y equals 0, x equals 0 or x equals 1. And when x equals 0, y equals 0. Here, the x equals 0 is a double repeated root, and since the coefficient of x to the power 3 is positive, the graph y equals x to the power 3 minus x to the power 2 take a shape like this. Y equals x minus 1 times x squared plus x plus 2. So, if you take the quadratic factor x squared plus x plus 2, the discriminant b squared minus 4ac equals to minus 7. And hence, this quadratic factor gives no solution. So, when x equals 0, y equals minus 1 times 2 equals minus 2. And when y equals 0, x equals 1. So, x equals 1 only and hence the curve crosses the x-axis at 1, 0. Remember, a cubic graph could intersect the x-axis at 1, 2 or 3 points, and since we haven't got enough information to know the exact shape of the graph, we assume the sketch of the graph like this. So here, the coefficient of x cube is positive, so x goes to infinity, y goes to infinity, And when x goes to minus infinity, y goes to minus infinity.